The art of the written word has changed over the years as people adapt to using computers and smartphones, but it will be some time before it's wholly obsolete. Despite the uncertain future, it can most certainly be said that writing utensils have been paramount to human civilization as a means of recording information, passing down stories, and drawing. Writing utensils have had to keep up with the ever-changing needs of this fast-paced world. For this reason, ballpoint pens began to overtake fountain pens in popularity in the 1940s, so much so that several companies vied to buy the rights to be the first manufacturers of it in their country. L'Atelier Biro is largely credited to be the inventor of the modern ballpoint, and when he filed a patent, the company Reynolds International Pen Company were the first to buy the rights in North America. 30,000 pens were sold in the first week, and in just 6 months, Reynolds had already made $5.6 million in sales. But why were ballpoints so popular? Well, for starters, they were made of these relatively cheap materials, which made them more economic for the everyday consumer. Furthermore, ballpoint inks are oil-based to make them viscous, but it's also why the ink dries a lot quicker and is indelible on many surfaces. Carbon black is an essential ingredient in black ballpoint ink. It is created from partial combustion of hydrocarbons, which makes it a better defined form of soot. It absorbs all of the visible wavelengths very effectively, hence it is one of the most versatile black pigments. In ink chemistry, a pigment consists of minute coloured particles suspended in a solution, while dyes are completely soluble in their chosen solvent. Ballpoint inks are about 50% dye because the undissolved pigment particles can clog up the pen's ball. The solvent is often benzyl alcohol or glycol such as ethylene glycol. Ethylene glycol can cause toxicity through absorption through skin and ingestion, but you'd have to ingest multiple ink reservoirs as the amount in ballpoint ink is very low. Benzyl alcohol is known to be a common skin allergen. Meanwhile, the fatty acid, oleic acid, acts as the ball's lubricant, allowing it to consistently roll even if the pen hasn't been used for a while. Blue ink colorants include phthalocyanine blue, crystal violet, a substituted triphenyl methane dye, and Prussian blue, whose intense dark blue color arises from electron transfer between its differently charged ion cations. Red inks often contain a dilute solution of the red dye eosine, created from the bromination of a fluorescent compound. Before the ballpoint were fountain pens and quills, the earliest of which had nibs made of iridium, a group 9 metal. It is one of the 6 platinum group transition metals, which share the qualities of high corrosion resistance, a large density, and extreme rarity. These properties, amongst others, make the platinum group the preferred choice of fountain pen manufacturers, with gold also being used because it has similar properties. Nowadays, stainless steels may also be used. One of the oldest quill inks is iron gal. It is made from gallic acid, crystallized ferrous sulfate, and gum arabic. Gallic acid is the monomer of galotanic acid, also found in iron gal ink. Ferrous sulfate is produced from the reaction of sulfuric acid and iron. Gum arabic is a water-soluble golden sap composed of various polysaccharides that acts as the binding agent which allows the ink to flow smoothly onto paper. Over time, iron gal darkens in color due to the oxidation of Fe2+ to Fe3+ by atmospheric oxygen. Well-made iron gal ink can last for centuries. Despite this, iron gal ink can fade on paper, and its ferrous sulfate content is largely responsible for the extent of the fading. Iron sulfate forms free radicals with oxygen that can decompose the cellulose in paper. It can also be reduced to iron sulfide in the presence of certain bacteria. The creation of iron sulfide causes the ink to be loosened from the paper, making the ink less permanent. Traditionally, phenol is added as a preservative to inhibit bacteria and mold growing in ink, and this gives some inks a very pungent medicinal smell. In present times, fountain pen inks have similar ingredients to ballpoint inks, but theirs are water-based instead. Finally, there is the humble pencil. Pencil, lead, is a non-toxic graphite and clay mixture. The clay is mainly silicon dioxide and minor quantities of metal oxides. Meanwhile, graphite consists of overlapping graphene planes, which are widely separated from each other, yet held together by van der Waals forces. This arrangement accounts for its perfect cleavage and its slipperiness, making it a versatile writing material. Graphite's carbon atoms are sp2 hybridized. In the plane, they form sigma-bonded hexagonal rings with each other, while the half-filled unhybridized PO bottles overlap perpendicular to the plane to form pi bonds. The delocalized electrons in the PO bottles allow graphite to conduct electricity in a direction parallel to the plane. It wasn't until 1779 that graphite was determined to be an allotrope of carbon rather than lead ore. Only one source of pure graphite has been found, in Barradale, Cumbria. Other graphite sources are not pure enough to be used on their own, so sulfur, gum, resin and glue are added to keep it stable. And thank you for watching, and I hope you've learned that when it comes to pens and pencils, if there's more to writing than meets the die.